Alright, I guess we better get back on track. So check the electrical panel. Mostly just make sure, like, at very least visually inspect it. I mean, we're looking for black, you know, carbon scars. We're looking for burnt up wires. We're listening for crunchy wires. You know, just give it a once over. Once we've declared a safe panel, we'll close the door and latch it. Before you turn it on, latch it all the way. Personally, and for those who were here yesterday, you can hear this again, after it's latched, in the imaginary scenario here, I stand off to the side to turn it on. Personally, I'm not dead yet, so it must be working. So this isn't a first-time startup. We're gonna move forward based on the assumption that all the motors are phased correctly. So we're not going to go through phase rotation today.
Yes. Well, if it's something that you're servicing regularly, that would be a fair assumption.
We'll performance test, but I don't go through like one pump, make sure it's going right. Okay,
Right.
The other pump, I don't.
You've already done that at the startup.
On the spring,
Right.
or the first time startup.
Right.
But we'll get there. If you have a flow meter, it's always a good idea to test each pump individually and make sure they're meeting their performance spec. If not, collectively, you and your customer can decide if that's a big enough deal to do something about. Alrighty. So, here we are again at a pump station with a pipe full of air. So, while we're going through testing some of these other things, let's get some of this air out of the pipe. Turn the speed pot all the way down because we're slowly filling up the pipe. We're not blasting it. And pick out your smallest pump, put it in hand, slowly dial it up. If you don't see pressure right away and you're already at the halfway point, I'll just leave it there for 5 minutes while I'm doing something else. I'll come back. Oh boy, there's a little bit of pressure. Once I see a little bit of pressure, I'll kick it up a notch just to make sure it's not going to skyrocket. And then as soon as we get to like 5 to 10 pounds, depending on the system and your familiarity with it, I'll just turn the pump off. What'll be happening is you'll see oscillations in pressure back and forth and up and down. And you want that to be at as low of a pressure as possible while the air is expelling out of their air release or out of an open zone. And I will continue step 1 through whatever. Slowly fill it up, get to 10 pounds, turn it off. As soon as it stops this back and forth business that we get when we have a pipe full of air, I'll get it up to 20 or 25 pounds, turn it off as long as it's not still jumping all over the place. Back on. Once we get above 40, in the 50 range, I'll put it in auto, let it come to pressure, fall asleep, and then I'll shut their isolation valve. Now we're testing the pump station. The way I like to do it is to shut the pressure relief valve off. You can do that by removing the plastic cover. It's hard to see this one. Man, the one I taught on 2 weeks ago, everything was like bam. But
Do you usually have an isolation valve underneath them?
we do not. We do not usually have an isolation valve.
Please put one on.
I know. On the bigger jobs we do. In fact, we were just asked by one of our bigger recent pump station customers if we could come up with an emergency parts list because they can't be down for any amount of time or else millions of dollars, right?
Fish farm?
Yeah. So after they got this list together, like fuses and transducer and stuff like that, I'm like, what about a diaphragm for the pressure relief valve? Because if that won't shut, I mean, you can't pump water up a 200-foot cliff if you don't have pressure. they said, oh, there's a valve in front of it. And I'm like, oh, all right, never mind. Because without that valve in front of it, they would be screwed, right?
Now the wind pump station would be until you can get it fixed with an isolation valve on them. Even on a 2-inch pressure relief valve.
Yeah, even a 1-inch.
Yeah.
Yeah, I'll turn the diaphragm around. I usually get a couple days out of that. It works.
Yeah.
Not always though. But like around here for irrigation, these guys can go without water for a couple of days, or the next day, or whatever. Okay, so on the pressure relief valve, did Terry go over pressure relief valves? How to adjust them? Sweet. Okay, so tighten it all the way down so it's not going to open. Ooh, that was easy. All right. Then, with our pony pump again, all the way down, put it in hand, dial it up. Now, what I'm looking for is when the pressure switch is going to close. So if we get it up there past where you think it should shut, and you're not getting any indication, you may have to throw your meter on there, test for continuity or voltage on the return wire to ground. Just to make sure, because not all of our systems shut down on high pressure in hand. Just the way it is. Otherwise, you can raise the set point in auto, but make sure that isolation valve is shut. But those are adjusted by turning this whole plastic cover.
Oh, yeah.
If you're on the top looking down, counterclockwise is a lower pressure at which the switch will actuate. Clockwise is a higher pressure. Now the pressure switch we want about 15 pounds above our set point. And I know that's pretty high for most systems, but our pressure switch is really a catastrophic fail-safe. If our pressure transducer fails at 0 or at a low pressure, and our pressure relief valve cannot dissipate that extra pressure, and this is our last line of defense. So at very least, test it. You know, once a year at least. So once we get that where we want it, let me rewind here. Once, if you haven't adjusted it and it closes where you want it to, you're done. If you do have to adjust it, test it 2 or 3 times and make sure that it actually will continue to do that. Because what I found is I'll bring it up to 90 pounds and twist it until it closes, and then I'll bring the pressure back up to 90 pounds and it doesn't close. 95, 100, oh, there it goes. So I got to twist it a little bit more. It's like, I wish they had little numbers on them. You could just twist it up to 95, bing, done. But they don't. So it's kind of trial and error on those.
Probably because those would come out of calibration too. We don't want to just trust them.
The Barksdale NEMA 4, they are numbered.
ITT NEMA 4 too.
Yeah. So I don't know, man. But yeah, I kind of agree with you on that. Like they would sort of go out of calibration, but I can't say. But I can say, test them every year. If they're not right, make adjustments. After you've made your adjustment, test it 2 or 3 times to make sure it's actually going to happen right where you want it to. Once you get that set, you go through the same process with the pressure relief valve. Isolation valve closed all the way. Smallest pump in hand. I mean, literally with the speed potentiometer, little black dial on the door. Like you can dial up the pressure. Just watch the pressure. You're dialing it up. Now the pressure relief valve you want to open about 10 pounds above your set point. I wouldn't put it any closer than that. What I found with those, and you guys can probably attest to this, they close at a lower pressure. So if you have a 65 pound set point and it opens up at 67 pounds, it'll get down below 67 pounds and then your pumps will kick back on. Well, it's still open, hasn't shut. So that's why you want it about 10 pounds above. Now the reason you want it below the pressure switch is because you want to give that pressure relief valve an opportunity to correct the problem automagically before you shut down the system on high pressure. Because it serves really a couple of purposes. If a pump doesn't slow down fast enough when a valve closes, whatever, deceleration time, extra pressure is created there can just go out and nobody even cares. Also, if you have a very big zone that's way down the road and it's running full bore, all these pumps are going, and that valve just goes shunk. This sends back a shock wave all the way back to the pump station. And if you don't have the pressure relief valve, adjusted properly, that pressure has nowhere to go. So you get a bounce back of the shock wave. Boom, 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 boom. Then you end up with 20 pounds above your set point static, which nobody wants that. I'll refer to my list. I'm going to go in some sort of order here. Did I tell you to reconnect all the tubing and the plug and the transducer?
No, you missed that.
Pretty basic.
Okay.
Pretty much assumed at this point.
Fear not,
There's
guys.
holes open all over it. Don't bump it.
If you left a valve open by accident or a tubing unconnected by mistake, you will be reminded.
And you forgot to close the panel too.
Well, we closed it and latched it.
Oh, okay. That's right, you did. Okay, now I
Yeah.
take that back.
Yeah, you
I
take it
remember you
back.
did that. Yes.
Well, but then I opened it back up. All right. So, yeah, the high and low pressure switches. Now, let's go back to the low water float talk we had yesterday. The low water float length, almost always, I'm going to say almost, but we try to always make that length piece of tape when we make the pump column, which is what, about a foot above the intake of the pump. If you have x-ray vision, can see through the water and to the pump intake, I give you full permission to make adjustments to the length of that low water float switch. If you're like me and can't see through, everything, don't make an adjustment unless you are very aware of where the intake of that pump is in relation to the low water float. Now, only in auto, which is another reason you don't leave a pump in hand. I'm sure somebody said that. Don't leave a pump in hand and walk away, because it doesn't care about pressure. It doesn't care about water.
Just knows it has to be on.
It just knows it has to be on, and it says, how fast? Okay. So in auto, we want to pull the low water float. This is an imaginary low water float. Ooh. Grab that cable. Ooh, ooh, ooh. Pump stops. Perfect. Throw it back in. Pump restarts. Auto restart. Also tested. So let's talk about pressure gauges. Our pressure gauges are a mechanical device, just like any, imperfect. Now, if we walk up to a pump station, and we being any of us, and I have one gauge over here that says 80 pounds and one gauge over here that says 20 pounds, we know there's something wrong. Probably with a gauge. But the moral of that story is check this gauge and that gauge. They should match the pressure here within a little bit. I mean, come on, we're not perfect here. We'll get to the filter here in a minute. The CW valve, or intake screen valve. CW valves, for those who don't know, are hydraulically powered. So we are supplying through a, like a sprinkler valve here. We're supplying water that's been filtered to this valve. There's these spray arms inside the valve with nozzles that are angled off so that the pressure going through them actually spins this whole armature around on a sealed bearing. So there's a lot of different possible places where that could fail. But, and I know we talked about this yesterday, so you guys get a more in-depth overview. At very least, you want to know for sure that there's water going out to it. Now, almost all of our systems are programmed to open that valve when the main pump is running. So if you only have a pony pump running, it's not going to open that valve. The assumption is that there's not enough water going through that screen to have, to worry about it clogging. Also, the pony pump probably produces just a little bit more than the screen is going to take. So it wouldn't make sense to run it anyway. But to test the valve while the main is running, best way I've learned is to just shut the ball valve in front of it, and you can hear the water hissing through, then it's good to go. Now if you're ambitious and want to know for sure if the arms are spinning around inside the filter and you can't see it, you can get a 10-foot chunk of PVC, 1-inch pipe, stick it up to the filter, and you can hear it going. Then you know that is working. Oh, here's one. Always get calls. My drive keeps tripping on device over temp. Well, does it run for a little bit before it trips? Yeah, it'll run for 10 minutes or so, and it'll trip every single time on device over temp. Say, well, I'd be happy to come out and fix that for you. However, there's one thing I'd like you to do. Get off the phone, go look at the drive's heatsink, which is on typically through the back of the enclosure, where the air comes in and goes, through the heatsink, forced by a fan to get the heat out. Well, at the bottom of that collects cobwebs, cottonwood, leaves, you name it.
Mice.
I say if you find that's clogged with crap, clean it out and you're done. If you find that it's clean, give me a call back. I am yet to have someone call me back. It's always what it is. In fact, if you pull open the drive manual, it will tell you that. But
Who reads a manual?
I know. I do a lot of tech support, and I've learned people will be out on site, they'll see a problem, they'll call you. Then I will pull out the manual that they have right in front of them, and it's like a bedtime story. Here, let me just read you from this book. And I'll just read them word for word. Okay, cool, I got it. All right, well, that's what we're here for, to help people out. But, all right, let's see what else we got here. Oh, now when we're talking about check all parameters, adjust where needed, that's kind of a loaded question. Are you talking parameters in the drive? Parameters in the touchscreen? What are you talking about? Well, really, we're talking about all. But what is there? 800 adjustable parameters in a drive?
I don't think there's anywhere near that number, but
Yeah, most people don't. What's really important is when I open some valves, do the pumps come on and maintain the pressure I want? Yes? Perfect. When I close valves, do they stage off the way they should? Yes? That's probably good enough for the drive programming. Alright? Now, I still will go through all the different screens in the touch screen and make sure nobody's been monkeying around with their fat fingers with their eyes closed. I don't know what I'm doing. You see that, Simpsons? I'm sorry, the fingers you are using are too fat. Homer's all, no! He's trying to, and this phone is huge. Anyway. I don't know what it is. People push buttons and then they get so far into trying to make it do something they can't remember what all the buttons were they touched. Yeah, right.
I think guys put drives in local. Just leave it there.
Yeah. Oh, yeah.
Man.
Drive won't ramp up.
REMLOC. You touch the REMLOC button. Yeah, what does that do?
It makes you call me.
I know some of these ones I feel bad, you know. They call me, they just are baffled, right? We go out there and local remote button, and I gotta bill them, right? Sorry, quit pushing buttons. So yeah, the cooling components, heat exchangers. I would say if you're gonna winterize a heat exchanger, put tape on one of the fittings and tubing. That way you know you're going to connect them right. Air conditioners, you don't need to do anything with those typically. Filter fan kits, you want to check the filters like we talked about. If they're really super dirty, probably time to change them out. You can always buy the filters from the manufacturer, or we stock them. Well, the newer ones that we use currently. Yeah, we talked about that. Painting and cleaning, come on, keep a clean pump station. We put hose bibs on like most of our pump stations, so I don't know. If you want, carry a hose in your truck. If it's dirty, you ought to have a hose in your truck. Yeah. If it's dirty, hose that puppy down. It's, takes a minute.
The other thing is bring a small shop vac.
Bring a small shop vac. Man, you're so right.
Suck up all that.
When you're starting a new one, bring a magnet. The electrician, he's gonna drill into something, he's gonna leave all kinds of stuff.
Telling you, we take a lot of pride here in making a pretty, appealing panel. You open the door, it's just spotless. And then I'll show up to do a startup, and the whole bottom of the panel's filled with metal shavings and zip ties.
He's a professional.
Yeah. Well, I went out on a job. The guy, he had totally wired up this panel. We shipped the panel and pump station separate. It was so clean and nice. I'm like, who's the electrician here? You? Good job. Oh, well, me? Yeah, man, this looks freaking awesome. He's like, thanks. Like, seriously, man. Thank you. Okay, so filter operation. Oh man, I'm sure I talked about this yesterday, but I know it's pretty tempting as a technician and or operator to walk up to the panel and just put the Omni on test and watch it flush, watch the limit switches work. Everything seems perfectly dandy. Well, you forgot one thing.
What did Terry say? The new guys. What did Terry say to do?
I'm sorry?
What did Terry say to do upstairs?
I don't know that I heard the question and answer.
Fail! You're out of here! Just kidding.
No, Terry went over it.
Well, there's not on all Omniods, and I'll tell you the fun way to do it if you don't have a three-way valve on the discharge side of the filter, that you can shut off pressure to the pressure differential switch and trick it into thinking there's pressure differential greater than 7 pounds. If you do have a three-way valve on that, you're in luck. Turn that puppy, it starts flushing, let it run a little bit of a cycle, turn it off. The filter is fully tested at that point. There's nothing about that filter you need to do.
Is that three-way valve a spec item, or is that something you guys put on automatically?
It comes on most SAF filters. It is a spec item.
I think it's better show them where it is.
Show them where it is?
Yeah.
Do you guys have an SAF filter?
Our systems just don't have any SAFs on
No, that's too
the
bad.
older systems.
Well, then no, I'm not.
Okay.
However, if you don't
It's your
have
class.
that,
You can do what you want.
that's right. I can screw this all up my way. Now, if you don't have the three-way valve to get the pressure off of that side of the pressure differential switch, you can just remove the tubing supplying pressure to that side of the switch, which will give you a nice shower, but at least you can go home knowing for a fact that that filter is 100% operational. So, just see here. The heat sinks, I mean, they're commonly looked over. In fact, there's a farm out in Caldwell. Every single year, the same guy calls me up with the same symptoms, and so far, he has not even attempted to do it himself. So I'll charge him, you know, $165 to go over there and clean it off and go home. I still don't get it.
He's probably thinking it's well worth $165.
Yeah,
And you couldn't clean it.
it's not his money. He's a city worker, I guess.
That's why he ain't doing it.
Bam. Municipal.
Hey, I found a wrench. Is this yours? It probably is. I'm bad about leaving wrenches, man. I've lost so many crescent wrenches.
Screwdrivers for me.
Yeah.
Bottom of the panel screwdriver. There it is.
So, does anybody have questions on winterization, startup? Does anyone feel I looked over something? I know there's some people in here that are probably thinking, man, I totally skipped over the...
Oh, you know, like when you're testing your pumps, deadhead amp checks, full load amp checks. When the pumps are running, when you basic look, listen, and feel. Do you hear bearings squeal? Does it vibrate? Is there
Yeah.
water spraying out of some place there shouldn't be spraying?
That's always a bad thing.
Here's your best friend.
Yeah, and actually, I'm glad you brought that up because I did overlook this. You know, almost all of our panels have a spec label, and that spec label includes the design point for all of the pumps when they were brand new. So, back to the flow meter discussion. If you have a flow meter, the best way to test them is have some water turned on, open some valves, give water a place to go. Start each pump individually. Doesn't necessarily have to be in hand, but they need to be going full speed for this test. And then close the pump station isolation valve, just feather it until it gets to the pressure on the design point, and then look at the flow. It should be pert near what it was, and if it's not, that's your opportunity to talk to your customer and say, hey, this is a 300 gallon a minute pump, and at its design pressure it's only producing 150. And they may say, I don't freaking care. I don't use that much water anyway. Okay, just so you know. Or they might say, holy crap, man, it's been 15 years since I've even thought about a pump. All right, so who knows? We get all kinds of different reactions. I mean, I've got subdivisions that we maintain their pump station where there's 9 homeowners. So if they've got a 15 horse pump that goes bad, they will personally call me, almost every single homeowner, asking what's going on, what's the timeline, how much. Oh, God, it's going to be $6,000. Ah! Because it's going to be divided 9 ways, right? The Amiad shaft has grease for it somewhere.
It's in the packet there in the back. Yep.
Oh, thank you. I usually go by what I call the crack test. I have my own names for everything. If the grease on the shaft is like dried and is starting to crack, I remove that old cracky grease and I just put on a dab of the non-melting, non-water soluble. It doesn't have to be this exact stuff, but this stuff works great. I took squeaks out of dryers. Done all kinds of cool things with this stuff. What else? What else have you got? Come on, Joe. All right. Well, that concludes my class. We're 6 minutes early, guys.
Nice.
Well, Phil.